Please give a round of applause for Simon presenting the application layer for the Interchain.
Yeah, thank you. Thank you. Today we're going to talk about CosmWasm. CosmWasm is the application layer of the Interchain. What that means we'll learn in a minute. And all the new latest and greatest features of CosmWasm 2 that we built with the team at Confio this year. A little bit about myself. I'm one of the co-founders of Confio, which is a development company behind our flagship product, CosmWasm. CosmWasm is a smart contracting framework for the Interchain. The Interchain is this idea of the Cosmos ecosystem where you have all those different layer 1 blockchains that can communicate between each other. I'm contributing to this piece of open source software for 5 years now, but I'm not doing that on my own. I did not invent it. We have a team of 10 people working on that. I'm just happen to be around for quite some time. So CosmWasm is what I call a second generation smart contracting framework. And what that pretty much means is we have EVM as the first generation smart contracting framework. And a lot of people see EVM and Solidity and smart contracts and what you can do with it and realize all the pitfalls that you have with it, all the great things, all the issues, and build different solutions with different optimizations and different kind of niche use cases. CosmWasm is particularly built for the multi-chain world. So it's not better than the EVM at what the EVM is good at, but it is good at serving the Cosmos ecosystem, this idea of you have all these different blockchains that are completely independent and sovereign, and they can all communicate between each other with a communication protocol called IBC. And CosmWasm is really made for that and great in that area, and not great for everything that you could possibly do on a blockchain. When I say multi-chain apps, that is the idea of applications that have components on different blockchains. So for the user, you can create an experience where an application uses a decentralized exchange on one chain and transfers some token to a lending protocol and does this and that interaction, and really provides complex, rich features that do not only access the local limitations or the local functionality of one particular blockchain, but everything else that you can connect to. And then you really get a higher level concept of what an application is, which can really be something that spans across all these different pieces of infrastructure. When we see multi-chain, at this point, CosmWasm is running on something like 100 different blockchains. So this is not something that is very often seen, because in many cases it is invisible or not really like the thing that is highlighted anymore, because the chains, they want to differentiate, they really want to be unique. But many of those blockchains, they use CosmWasm. So for example, in this event here, which is sponsored by Neutron is entirely based on CosmWasm. We have Atom Accelerator representing the Atom blockchain that is using CosmWasm as well to enrich the functionality that you have on this blockchain. So looking a little bit, tiny bit of technical stack details here. Where CosmWasm fits in this idea of a modular blockchain setup. The whole Cosmos idea is about building your own custom blockchains and being able to swap out and customize everything you want. So at the lowest level of such a blockchain, we have block production. And the first two options that we have here, those are pretty much different ways to produce blocks. The CometBFT is an implementation of the Tendermint consensus. Gordian is a different one. We have Rollkit as a block producer that is built for layer 2 solutions. On top of that, we have an ABCI application. ABCI is the interface between the tandem and block production and the application layer. And everything that you have in this orange boxes, including the ABCI application, is something that you need to finish when you deploy your software to your blockchain. And every time you change a tiny little bit in any of these boxes that is orange, you need to deploy new software to all of your validators. Everybody needs to upgrade to the latest version. If they don't, you fall out of consensus, you don't produce blocks anymore. And this is something you don't want to do on a weekly basis or on a bi-weekly basis. So this is why we have this green layer on the top, which is a dynamic layer which allows you to swap out functionality at runtime. And for people who are familiar with the Ethereum ecosystem, this is the very classic use case of smart contracts, where arbitrary users can upload their applications. But we see a lot of CosmWasm usage where this application layer in the top is not opened up to the general public, but it's only the maintainers of the blockchain that say, we want to install our applications that are specific and unique to our ecosystem and iterate on this application layer in a different pace than the other part of our team, which is taking care of the node layer. So yeah, you can really split the work between different parts of your applications and develop in different release cycles. You can do emergency patches in this application layer very, very quickly without even bothering about the validators. So this separation goes way beyond just smart contracts. So CosmWasm, this is part of the name, is WebAssembly based. So the advantage of this is we have a specification that is there, that is great, that is free, that is supported by huge players in the browser ecosystem. It's fully sandboxed. It's getting better for free all the time. The tooling is getting better. The optimizers, compilers, all of that is getting better all the time without us doing anything. And that's just great. You can utilize that. CosmWasm smart contracts, as well as the virtual machine running the contracts, are built in Rust. Rust is a nice programming language. It's very popular amongst blockchain developers. It's a programming language that enforces discipline. And I think, yeah, not being able to write sloppy code is something that is quite useful if you are dealing with other people's money. CosmWasm uses the actor model to prevent reentrancy attacks. So you are not, in CosmWasm, you're not able to call a different contract synchronously. You cannot just simply invoke a function on a different call, on a different contract. Instead, what you can do is you run your contract. At the end of your function, you say, okay, now I pass a message to another contract. And this message then contains the information or the action to be executed on this other contract. And this way you can compose. But yeah, it's a different model. It's a model that is well established. It's coming from asynchronous programming, networking. It works very well with how messages in Cosmos SDK work. But yeah, it might be a little bit tricky to get used to this idea if you're coming from an Ethereum background. But it has advantages, and yeah, we have never seen a real reentrancy-like thing issue in production. CosmWasm, and this might be controversial, but it comes with an integrated built-in upgrade system. So every contract that you instantiate has an owner or an admin, how we call it, and this admin can upgrade the contract to a newer version of the software. This admin is optional, so if you say there's no admin, then you pretty much say nobody can upgrade this contract, which makes it immutable. But we want to make sure that we don't need any hacks in order to allow people to make sure, yeah, your application can be upgraded, because I mean all of the software around us is something that is not perfect the day we launch it. And yeah, you can do as many audits as you want. Most likely there will be this tiny little thing that you want to change at some point. And with the built-in upgrade system, we ensure that everybody uses the same system. That makes it very easy to integrate into Explorers. That makes it easy for community members to review if something is upgradable or not, by which address it is upgradable, if this address is something that is secured. For example, it could be a DAO that is able to upgrade a contract. It can be multi-sig. It can be just some person's ledger. And yeah, it's really up to the application to figure out the security system there, but we provide the framework. We did a lot work on documentation this summer, so we dedicated pretty much 4 months of the entire development team of CosmWasm to write documentation. That was really the main focus, the main feature, because yeah, over the course of the last 5 years we realized, okay, we can't outsource documentation. It cannot be done by some technical writer. We need to really write it with the team that is building the software. And that takes a lot of time, it takes a lot of effort. That is the feature, so in that time we did not expect any other feature development. And that helped us solve the documentation issue that we had and that we were criticized for a long time. Yeah, now I come to the second part, which is the latest and greatest updates to CosmWasm 2, which is something that we launched earlier this year, which is not like changing CosmWasm in a massive way, but is this incremental improvement of all the good things that we already have, but also, yeah, breaking some APIs that we thought, okay, we did not get them right first time, but now we have the opportunity to change them. CosmWasm is a smart contracting framework that is really built for IBC applications. IBC, I don't know if everybody's familiar with the term. It's really this idea of contracts or even blockchains being able to communicate with each other by just sending arbitrary messages between blockchains. So the protocol itself is unfortunately often understood as a token transfer protocol, but it's much more generic than that. It's just a messaging communication protocol. So you can send arbitrary data between blockchains. And one of the standard IBC protocols that we have is token transfers. But there's so much more. And with CosmWasm and IBC, you can build your custom protocols. So you just have 2 contracts on 2 different chains. They agree on the protocol that they want to communicate between each other, and yeah, you just design your application-specific protocol. You pretty much invent your own language, and yeah, IBC is like the phone line, and you have two ends of the phone line, and they agree on a shared language to communicate. So yeah, this is what CosmWasm and IBC is good at. Message transfer is this IBC message that allows you to transfer funds from one chain to another. So we did some improvements there. There's ICS20 version 2 support coming, which is the protocol that allows you to send tokens between chains. We have IBC callbacks in the latest version of CosmWasm, which allows you to react to cases where funds are sent to your contract from a different chain, and then the contract might want to react to this. A very typical use case is you have an IBC service contract where somebody is sending you a payment along with a job description. You just receive, okay, here's the money, now please do this and that for me. And with those callbacks, you have the opportunity to react to this incoming funding and trigger some action based on that. So yeah, you can pretty much get notifications for arbitrary package deliveries on both sides of the communication. We have support for IBC fees. because IBC requires you to have an entity, an off-chain entity in between, which is called a relayer, and that is reading information on the one chain and relaying that information to the other chain. And that relayer right now in the ecosystem, a lot of the relayers are either funded by foundations, or they are doing that at their own cost or for promotional purposes. But there's no well-established fee model to pay those actors. But in order to be decentralized and to not depend on someone paying those relayers, we need to really bake in the incentivization model in the protocol. We have a standard for that, IBC fees. This is now possible with CosmWasm as well. We have gRPC queries and any messages. That is pretty much the way for a CosmWasm contract to interact with the rest of your Cosmos chain. So a query is the ability to read only information from the state of the blockchain, to query modules, other modules that you have. For example, in Cosmos, there's a governance module, there's staking module, there's all kinds of interesting modules that most of the chains have, and you can use the gRPC queries to query all of that information. Everything that the chain makes available to clients, you can pretty much make available to the contract as well through this generic interface. And there's any messages, and any refers to this protobuf any type that you may have come across. And that allows you to send instructions to other modules of the blockchain, which may be CosmWasm contracts, which may be some other module that is an EVM implementation, that may be some modules that are doing something completely native. So you have all of that interaction streamlined and prettified with CosmWasm 2. We work a lot on more efficient storage. So the first version of CosmWasm heavily relies on JSON encoding for values. And yeah, we have a great storage library that allows you to organize your data in the way that you want. We now settled on MessagePack as the second generation of encoding, where we say we want a nice trade-off between debuggability, human friendliness, and performance. And MessagePack is giving that to us by pretty much being a binary JSON that has binary fields that makes a lot of things much more efficiently, because you don't need to do escaping and all of that stuff. And that encoding is what we use in our new storage library called Story. So that is really for the more advanced applications that have a lot of traffic and that want to keep the gas cost low while processing a lot of data. Yeah, there's improvements for submessages. Submessages, I talked about this idea earlier, where contracts can send messages between each other. So submessages is kind of the idea to say one contract sends a message to another contract, there's something processed, and it gets a reply, which is a message back to the original contract when this operation finished. So we streamlined those interfaces to make it nicer. We have new signature verification algorithms, which is something that you call pre-compiles in Ethereum. We just call them crypto APIs that the host provides to the contract. We have SecP 256 R1, which is popular and needed for passkey verification in a contract, and there's BLS 12381. Signature verification, which allows us to do a native DRAND random beacon verification, and Ethereum block headers, which we can now efficiently verify in the contract. There's a bunch of work on mass migrations. So I talked about upgradability before. We have some very heavy users that are very advanced that say, okay, we have a lot of instances of all of our contracts, and sometimes I don't need to upgrade one contract. But for example, I have this exchange or other financial product where I have all those pools, and each of those pools is a separate smart contract. And now I want to upgrade a dozen contracts at the same time, 100, 1,000, 10,000, up to 750,000 contracts at the same time. This is due to the way people use contracts in CosmWasm. So if you do account abstraction, then you have this problem as well. Suddenly, every user is their own account, contract instance, and you need a way to upgrade all of your users at the same time. So we're working on that and making some improvements there. That is all I want to share today. Introduction to CosmWasm, what we are working on in CosmWasm 2. Happy building with CosmWasm. I don't show any code today. Thank you very much, Nico, yesterday for the presentation on Abstract, which is CosmWasm Builders. We are going to have a workshop tomorrow at 6, where Pino from our team is giving a workshop on CosmWasm, which shows you some code to get your hands dirty. And yeah, with that, thank you very much. I'm out of time. We don't have time for questions, but if you find me, hit me up. Oh, we have time.
Would anyone like to ask any questions? No, in that case, big round of applause, please.
Thank you.